We are so glad that you've decided to join us today for Databricks Transforming Energy, Mastering Asset Health and Predictive Maintenance for Pipelines. This webinar is for you, especially if you find yourself within the oil and gas space and are looking for ways you can maximize your impact at your companies during this relatively volatile time in the energy sector. So today we're going to start, let me make sure that my slides are up because they are not. There we go. Today we're going to start with a 5-minute overview and introduction, and then I'll present about a 15-minute energy market overview. Following that, Brett will be showing a demo where we've implemented a pipeline monitoring and work order system using the Databricks platform. Brett will dive into the details to show how to make a solution that can allow for constant monitoring and managing of pipelines in the wild. After the demo, we'll have about 15 minutes for Q&A, where Brett and I will do our best to answer any questions you might have. Before I get started on the introductions, though, I need to mention that Data and AI Summit is coming in just a few short weeks now. There will be more than 20,000 people there already signed up, and with over 700 breakout sessions, there is guaranteed to be something that applies to you in your work, whether you're in management or whether you're an individual contributor building solutions. If you're not able to be there in person, we do have a virtual option, which will be streaming the keynotes and many of the selected sessions. Speaking of the sessions, at the Data and AI Summit, the Databricks Energy team will be hosting an energy forum there with networking and a variety of content from our friends in the energy space. This is something you don't want to miss. This is our big event every year. It's a great opportunity for you to find out what's coming in Databricks, as well as to learn new things you might not have known before. Registration is open, so I encourage you all to be there, and I hope to see you there. I will be there as well. So first, who are we? My name is David Morton. I'm a 10-year energy industry veteran with over 20 years of software development and analytics experience behind me. I've helped everyone from JP Morgan Chase to Chevron to several smaller companies use technology to achieve their business goals. Most recently at Chevron, some of the projects I worked on included an anomaly detection algorithm for oil tanks to help manage potential loss, ML systems to analyze subsurface data for the oil sands in Canada as well as in the Permian, and also linear programming models to optimize the value chain. I joined Databricks in January of this year.
Hi, how are y'all? My name is Brett Albo. I'm a solution architect here at Databricks as well. I joined about 6 months ago. Before that, spent about 8 years in the oil and gas industry, specifically at EOG Resources and Apache. Took a little break from oil and gas where I spent time in the analytics world at HEB, if y'all are local here to Texas. Y'all know HEB, and then most recently spent some time as a data scientist and data engineer at Meta, specifically focused on Instagram. So, like I said, joined about 6 months back, and yeah, really excited to be here.
All right, so now that our intros are done, let's take a few minutes to discuss where we are in the energy industry right now. As is often said, timing is everything when it comes to implementing the right solutions. And there's a reason that we're going to be demoing predictive maintenance today and not, say, more upstream centric demos. My hope is that over the next 10 to 15 minutes, you'll gain an understanding of where we are in the industry. So you'll be able to make wise decisions when it comes to your data ecosystem. As a caveat before we start, there has been a lot of change in the energy industry. I started on this slide deck about a month ago, and since then, there have already been several changes to the market. So while I think the following slides indicate the general direction that the industry is moving, it's important to remember that many of these things can and do change on an almost daily basis. So what I'm going to do in this section, I'm going to spend a few minutes talking about the challenges and headwinds we're being faced with, followed by the opportunities that these challenges present. I'm going to wrap up by spending some time on how Databricks is uniquely positioned to help you increase your margins and profitability wherever you are. But first, let's talk market challenges. The big story this year in the oil industry is the reduced trading costs of crude. Crude, which was trading between $70 and $80 per barrel earlier this year, is now trading closer to $60 to $70 per barrel. If you've been in the industry long enough, you're probably used to some of these price changes. You've seen them before, and you know what that means for the industry as a whole. Typically, in the early months of every year, we see an increase in crude oil prices as demand begins picking up for the summer season. The increased use of air conditioning, as well as the increase in summer travel, usually serves as a stable prop for the summer prices. But what we're seeing this year is the opposite. Instead of going up, the prices are going down. There are a few reasons for this. First, consumer sentiment is on the decline. As the cost of goods are expected to rise, many people have been tightening their belts and spending just a bit less. Hotel bookings are down about 7 to 8% over last year, an indication that travel is being curtailed going into the summer season. This reduction in travel, combined with the expected reduction in purchases, translates directly into lower demand for oil and gas products than what we would usually see this time of year. Adding to that, the OPEC plus countries are planning an increase of 411,000 barrels per day by next month. Much of this may be related to a perceived opportunity by these countries to take advantage of some of the market volatility and increase their market share worldwide. Whatever the reason, the increase in supply combined with the decrease in demand is going to add some downward pressure on the price of oil products in general. We can see some early signs of this change already. Frac crews are unfortunately down about 15% industry-wide. In the Permian, it's down about 20%. Because these fracking operations break even when the price of crude is about $60, we might see a bit more reduction in activity in the Permian if prices continue to stay low. We're also sadly seeing some layoffs, reductions in force, and offshoring happening increasingly across the industry. There is no doubt that this is a time of transition in the energy sector. So with all that, the general theme of this year seems to be wait and see. Drill baby drills kind of turned into delay baby delay, as a lot of companies kind of hold off on their greenfield projects until there's just a bit less volatility in the market. What's more is that most companies out there are planning to do more with less in general as belt tightening continues. That's it for the bad news. That's all I got to say about the bad news. The good news is that every market challenge comes with opportunities, and we're going to talk about those next. First, refineries. Refineries tend to win when crude prices are low because refineries pull in raw crude and make produced material out of it. So their feedstock, which is crude, that's used to produce the things they produce, is effectively on sale from their perspective. This allows them to save more on costs, even if they keep their outgoing prices the same. One caveat here, however, is that if consumer spending continues to be low, this may result in more of a break-even scenario than a gain for the refineries, but we're just going to have to wait and see on that. We're also seeing a big uptick in deep water plays. 58% of the FPSO, which are the floating production, storage, and offloading vessels, you can see one in the picture here, 58% of them are conversions. So there is certainly something happening in deep water. This shift has also been enabled thanks to several new engineering developments in drilling, such as NOV's 20,000 PSI blowout preventer, which I learned recently is about 3 to 4 stories tall. It's a behemoth, and it's making deep water plays more feasible than ever. If you look at the slide here, you can see the tiny little people on the right picture down at the bottom. Also, autonomous drilling. So at the beginning of 2024, at an offshore rig in Campos Base in Brazil, the first fully autonomously drilled well was achieved by SLB. This well had a rate of penetration about 60% higher than traditional wells, so it was able to drill at about 80 meters per hour. The entire well was over 2,500 meters deep, and the first 1,100 of that was drilled within the first 24 hours of breaking ground. AI and fully autonomous drilling is giving us order of magnitude increases in rate of penetration, which of course will translate directly into lower recovery costs. We're also seeing a lot of work done towards the end of gathering more information from the well environment. Traditional MWD, or measurement while drilling, uses what is known as mud pulse telemetry, in which the bottom hole assembly creates pulses in the mud that flow through the well and are interpreted topside. The trouble with mud pulse telemetry, though, is that it is painfully, even criminally slow. It typically runs at about 1 to 3 bytes per second. Even the fastest MPT, known as high-speed mud pulse telemetry, or HSMPT, can only run at about 12 bytes per second. So for scale, this would mean your favorite 3-minute song would take about 3 to 4 days to download. It's hardly high speed. Obviously, with slow speeds, decisions have to be made about which data is the most important to send and which isn't. The variety of information has to be carefully weighed against the slow velocity of the data. Wired pipe, which has been around for a while, but is just now beginning to see some commercial use in active wells, that increases the data throughput from 12 bytes per second to about 56,000 bytes per second, opening the door to a greater variety and velocity of subsurface data being generated and consumed in real time. With these order of magnitude increases in data throughput, wired pipe is getting much closer to having a positive ROI when combined with automated drilling. Since the mid 2010s, we've also seen an explosion in the use of drones, robots, and IoT devices to automate many of the rote tasks associated with gathering measurements. Blowout preventers can now send up to 10,000 data points per second. Digitally controlled valves are being deployed along pipelines to maximize safety and prevent loss. I myself have personally worked with drone technology at refineries, and I've seen use cases in which Boston Dynamics Spot the Dog robot, pictured there on the left, is used to gather metrics from analog sensors in various environments, relaying those measurements to the back end for digital twin solutions and for general analytics. All of this automated drilling, wired pipe, and robotics are just a few of the ways we're seeing the oil industry really lean into data gathering to improve processes, which of course is driving the need to have a platform that can enable data gathering, storage, and processing and provides a low barrier of entry to using that data in ML and AI. So in sum, I would say this year, the theme is really all about operational efficiency. While we may not see increased drilling activity this year, this momentary lull provides us with a unique opportunity to put in place better efficiencies to reduce recovery costs going forward. So how can Databricks help? In short, we spend all day, every day, trying to find more efficient ways for you and your entire team to make use of the data you're already collecting. Talk about some good options of things to focus on this year specifically. Some of those things might include doing some postmortems on wells to find missing efficiencies, finding some ways to open up data to the enterprise and not just to the people in IT, implementing predictive maintenance techniques as well. These are just a few of the ways that you can make small investments this year that are guaranteed to have a positive return on investment and be more impactful in the situation that we find ourselves in right now. So in sum, it's prime time to not only prepare for the next oil boom, but also to maximize our ROI and efficiency in current projects as well. So still, why are we, Databricks, uniquely positioned to help you in the energy space? First, we have 3 teams in-house that are solely dedicated to helping the energy industry specifically. Our entire reason for being is to take the data that has previously been made available only within IT departments and open up the ability for analytics across the whole enterprise. So your facilities engineers, reservoir engineers, geophysicists, geoscientists, geologists, et cetera, they can all interact with the data without having to know SQL or Python. We truly believe in data democratization, and that's really what we work to enable. Our AI and BI tools can help even the least technical employee find valuable insights from the data they already have access to. In short, we can help bring some level of sanity to what can be a very challenging task of data management and governance. So in a moment, I'm going to hand things over to Brett for the demo. But before I do, I want you to keep a few numbers in mind. Just 4 days of unplanned pipeline downtime can cost around $5 million. That is a non-insignificant number. More so, companies operating offshore lose an average of about $36 million a year due to unplanned downtime. Much of this money could be saved if predictive maintenance techniques are put in place. According to the US Department of Energy, predictive maintenance saves roughly 8 to 12% of operational costs when compared against preventative maintenance. So keep these numbers in mind as you see the demo. What Brett's going to show you isn't magic. It certainly is not out of the reach of your organization. It just simply takes someone with a vision and drive to go about implementing the solutions. The cost savings are there for the taking. So with that, I'm going to turn it over to Brett to go through the demo of our predictive maintenance POC.
Cool. Hey, thanks, David. So we can go ahead and move on to the next slide. Davis talked about discussed some of the key challenges facing the energy industry. Particularly, he focused a lot on operational efficiency. Now, I would love to, as he mentioned, shift gears and really show how Databricks can specifically our data using our data intelligence platform, can directly address some of these challenges, focusing specifically today on predictive maintenance on our assets. And so, starting off, we've all seen headlines like this: pipeline explosions, gas leaks due to something that could have really been preventable. These aren't just operational setbacks. They really represent significant safety, risk and environmental hazards as well. While this particular article highlights an incident in Oklahoma, it really shows a critical vulnerability that all midstream gas operators face. That they all face. Asset failure and unplanned downtime events are incredibly costly, both financially as well as to the environment. Next slide. So David highlighted some of this already. These numbers on the screen are really large. And these are some of the things that we're seeing for complete failures, like was highlighted in the article above. But even taking out complete failures and looking more at just like unplanned downtime, as David highlighted, a mere 1% downtime rate, which is about 3.5 days, can result in $5 million of annual loss. And then, as he highlighted, offshore operators are really disproportionately disadvantaged with bigger operations that can result in $38 million for unplanned downtime. Next slide. So what can we do about it to make sure that we aren't highlighted in an article that was shown above or facing these huge expenses from pipeline failures and downtimes? Well, this really brings us to the concept of predictive maintenance. Traditionally, maintenance has been reactive, which is fixing things when they break, or preventative, which is scheduled maintenance regardless of the condition. Predictive maintenance moves us into more of a proactive action state. Instead of waiting for equipment to fail, we use data to predict when a failure is likely to occur. So if you take a look at this graph, as equipment performance degrades over time, operational costs will increase. Reactive maintenance typically happens later in an asset's life when, after significant degradation or failure, leads to really high operational cost. And scheduled maintenance occurs before we are seeing any performance degradation, leading to unnecessary spend on really perfectly healthy assets. So, predictive maintenance really aims to intervene just in time based on the onset of performance degradation, allowing for intervention at a much lower operational cost before failure occurs. So, right at that elbow point of this chart. This is achieved by monitoring asset health indices based on real-time signals and building really a knowledge base of prescribed next best actions on reoccurring issues, making it really easy to solve these issues before they get out of hand. Next slide. So we've obviously established the cost perspective of things and really why it's so important to lean into this predictive maintenance movement. And this diagram illustrates how predictive maintenance for gas pipelines with the data intelligence platform can entirely be built on Databricks from start to finish. This slide is really the culmination of how Databricks brings together all the pieces to make this possible. You can really think of Databricks as a unified engine for analytics, data aggregation, and AI. And once your data assets are on this unified engine, the speed of development and insights really increases exponentially. So just sort of walking through this diagram, we start with all your various data sources: real-time telemetry data, operational data from ERP systems, detailed signals from flow meter sensors. All of this raw data flows into the platform through data pipelines and streaming processes that we provide out of the box. These data sources are stored in open data formats, allowing for really easy access and high interoperability with a variety of systems. Once the data lands within your cloud system, we like to structure this data what we call the medallion architecture, creating layers of increasing quality from bronze, silver to gold tables. Just to explain that a little, bronze layer holds the raw, unfiltered data. Silver layer is where we clean, filter, enrich data, change column names, add calculated columns, things of that nature. And gold layer contains these really highly aggregated, curated data sets, sort of fit for purpose, that are optimized for analytics and reporting. This architecture, the medallion architecture, really provides a simple and standardized data model that everyone in the organization can truly begin to trust and access as well. So great, we have our data. But now, crucially, we need to figure out how we're going to govern this data, and that's where we bring in Unity Catalog. Unity Catalogs are a unified governance solution, which really makes it easy to secure, share data, track lineage, things of all nature, and not just data, all your assets as well. Dashboards, pipelines, ML models. Unity Catalog can really handle and govern it all, and make it extremely easy to really have trust and faith in your data and what all what all your data is impacting. Now, I really want to drive this point home. When everything is on the unified and governed platform, the possibility of what you can build and how quickly you can build it is really impressive. It makes the time to develop these data assets so much faster. As you can sort of see in that top box, whether you're doing AI BI dashboards, ML model development, things of that nature, it's all extremely easy to do, and you can scale up really quickly. Sorry. In the demo I'm about to show, we're going to actually pretend that a pipeline control operator is constantly monitoring a custom-built Databricks app interface. This app isn't just showing raw data, it's displaying real-time asset health indices derived from this process sensor data that we've shown through our medallion architecture. The app might flag specific areas or assets that need to be paid attention to, that are non-compliant based on some level of performance degradation. Now, when the operator sees a critical alert, they can easily interact with the app to initiate an action. This can mean generating a service ticket directly within the app or triggering some sort of service dispatch to a maintenance team. We're actually going to do that within our app. We'll show you that here momentarily. But really, the beauty of all this is just all of this, including the app, which we're excited to show, is all on this one unified platform. And really, start to finish, makes this very easy to stand up and get going. So, with that, David, I'll start sharing. Um, and awesome. You should be able to see my screen now. Um, if you have questions, just to sort of reiterate, we have folks. Um, can y'all see my screen? David, can you see my screen? Thumbs up.
Yes, I can see your screen.
Okay, cool, awesome. If you have questions, we have folks online, other solution architects here at Databricks. Feel free to send them in the chat, and they'll try to answer them. And then, like David mentioned, we're hoping to have a few minutes at the end for Q&A. So I want to start off by really just showing this app that we present today. Traditionally, Databricks has really been thought of maybe more of a back-end data processing engine. Something where you can do all the ETL, do some model development. But I'm really impressed with how we've taken this leap and sort of presenting this data out to end users. Our last Transforming Energy series, which you can definitely find the recordings for online, really highlight our AI BI dashboarding tooling, our Genie interfaces to interact in natural language. And this is our first time that we're really showing Databricks apps, which is Databricks Apps is a product that we just released of allowing you to really completely deploy data-centric apps all within Databricks as well. And so it makes it really easy. Your time to development super fast to once again, you already have your data assets, your ML pipeline sitting there within Databricks. Now you can easily deploy an app as well. So we'll dive into the specifics of that in more detail momentarily. But this is our app. As you can see, we get a nice little overview of our pipeline that we're monitoring. Once again, the scenarios that this would be up on some sort of control room that they're constantly monitoring. Data is flowing in here real time. Obviously, the green segments are good to go. We don't need to really pay attention to those. But then we're also seeing some yellow and red segments as well. If we dive into one of these yellow segments, this is getting to that realm of predictive maintenance. Obviously, these are being flagged by our system for needing to pay attention to. And so we can dive in, we can see the specifics on the actual segment, actual locations that are maybe showing some signals to look at. We're not detecting any leaks yet. Once again, that would be that reactive maintenance. We're just sort of seeing some non-compliant segments that we want to dive into a little more. Once again, no leaks, but what's really cool is now we can start to once again pull in. We have our telemetry data, which is sort of signaling that these aren't compliant, but we can also have some ERP inspection data that's easily merged in and giving us some insights into when the last inspection was, things of that nature. I want to touch on our first really use case of AI and sort of how we're incorporating LLM into this solution, with this recommended service. This recommended service is using a function that we call batch inference that's actually applying an LLM model on top of a number of rows that are stored in our systems. And so in this case, we have a last description potentially that's talking about, hey, the last time the inspection went out, our service field technician input some raw data. What this is actually doing is it's reviewing line by line that paragraph of raw data and recommending a service that we want to actually perform on this asset once again to get ahead of any potential reactive maintenance steps that need to take place in the future. And so we can see, like in this case, for segment 4643, it says we need to potentially do some clamp installation. Once again, this was not selected by a human. This read, a model more or less read this description and recommended this. And so we can go through and we can easily create a work order. In this case, we know that there's crews in the area. So we can type, crew in area, give, a look. Some nature, obviously more official than that. What this is doing right now is it's actually going out and writing to a Delta table. Now, this could also write, once again, this is a custom app, so you can write this to other systems of record that you have, some sort of work order system you may have. I don't know if you've been paying attention, but we just recently acquired Neon here at Databricks, which is like a Postgres open source solution. So, be on the lookout. Maybe there's some options there to maybe enhance this feature and functionality even more in the future. But anyway, so now we've once again quickly been able to identify a leak, order a service to this particular asset, and go from there. Now you also see some red instances. Once again, this is more of that reactive state, but we're able to quickly do it. The data is streaming in real time. These tags are updating. We can dive in, see the individual pieces of the pipeline that are showing leaks, get a pressure profile on that system. So once again, we're looking at our inlet versus outlet pressure. We see a big drop around 12:45 in the morning, and we can obviously take action as needed. Databricks doesn't just store tabular data. Say you had image detection or images being stored on all your assets, you could easily display those as well. Once again, here's that sort of last inspection note that was put in that our recommended service is reading. We had actually recommended pipeline patching, and so maybe that gives a really good indication to the crew of what this could be going wrong. Same thing, we can create a work order as we've seen and sort of go from there. So, this is one scenario of how we've laid out this particular sort of dashboard monitoring solution. There's many more, and so once again, this Databricks apps is completely built within our platform, and so that's the solution. I want to go back and sort of talk about some of the key fundamental pieces for these last 15 minutes or so. The first, obviously, is we need to get our data right. And so for that, we've leveraged our technology called DLT pipelines. DLT pipelines is our sort of declarative pipelining solution that allows you to easily create these DAGs and really keep your data sets completely in sync, updated all the time. You can run different jobs and things in parallel, and it's all really easy to set up. Historically, to do stuff like this, you would have had to be really good at Spark or Python or Airflow or different sort of data engineering, really advanced features and languages. But this is all really declarative. So if you can write SQL, you can now create these really expansive pipelines. And so to just sort of show you that, each one of these pipelines reads from a file. It reads from a DLT file. I'm not going to spend a ton of time in this because I know notebooks and stuff aren't the funnest to look at. But I do just want to show you how easy it is, to really set up these pipelines. And so, for instance, we have a bunch of tables that we're bringing in as raw bronze data. Once again, that bronze layer is that raw unfiltered data. It's really just a copy of the data from its source system. And so we're more or less creating in this case like a streaming table, which is like an append only type view that says, hey, as files are read into this volume, go ahead and just add them into the streaming table, which is great. That's not the fanciest thing in the world. But what makes this really interesting is then we can use this as an input to other tables downstream, and it's really straightforward to do so. Once again, this is a bronze table, so there's nothing really upstream of that, or downstream, sorry, maybe I'm getting confused. But what's really interesting is if we want to leverage that bronze table, it's really as easy as just adding, once again, creating another view, another table, another asset you want to create. But if we add this live precursor to that table, it's going to know, hey, this pipeline segments bronze is declared somewhere in this SQL script. In one of the cells, you're going to see a pipeline segments bronze being declared. And that live notion tells you, hey, go out and create a dependency for this table on this table. And so as you sort of build these out, once again, this is just SQL. This is a select star, and we add some lat longs to it. All you got to do is know SQL, and then you can really quickly and easily build out these very complex DAGs. So super straightforward, super easy to implement. Takes it to where you don't have to be a data engineer to incorporate some of these features. You can have this update, I think, once, like pretty much in a streaming fashion. You can schedule it to run throughout the day and look for new files. And what's really neat is as it knows as new files land and this inspections bronze starts to update, all the dependencies downstream will update afterwards. So it really keeps everything in sync. Once again, very declarative way to have these pipelines go. So that's how we sort of got our base data sets. I definitely implore everyone to dig into DLT and how you can leverage it going forward. The other thing that was really cool was that we implemented here was our use of AI query. So I mentioned this as this was that way of we're in a batch inference style, being able to apply an LLM model over our data sets. And so you can see in this table, we have this description. The idea is that this is that sort of free text input um, field input field, mouthful, but that it could have spelling errors. They're just typing up their notes, right? And we really want to get this down to say like, what is the recommended service that should happen on this table? Well, that's where this AI query function comes in. So this AI query function more or less takes in a few parameters. It takes in a model that you want to pass. In this case, it's the Databricks hosted Meta Llama is what we're using. And then it takes in a prompt. And so for this case, I'm saying, hey, the following comments is the inspection notes on a pipeline field log. I want you to categorize these into one of the next steps. This should be one of the following options: general service, no next steps, coupling replacement, pigging, valve maintenance, blah, blah, blah. Um, this then is going to, as we execute this, it's going to actually go through and go line by line, apply this prompt, and then I've actually declared what I want the response format to be. So in this case, I want it to be the type to be a text. That way it doesn't sort of hallucinate. It sort of refines what actually is going on and what's going to be output from this field. And so, really straightforward. Now you can see we've have this description, and we're saying, oh, it should be a clamp installation. In this case, no next steps were found, and so that's what's recommended. Now, one thing to note is AI query is just one of many of our AI functions that we have available. Y'all can literally start leveraging this today. We have a lot of different ones out of the box that are ready to go. You can do some classification, some extraction. You can fix grammar. I've actually showed just a few more instances where maybe we don't want a recommended next steps. We just want to summarize this. Like that's a long paragraph. We want people to be, we want to be able to serve this up in our app. We want this to just be much more summarized. Once again, now we can execute this. It's going to go out. We're just passing in that description. And so what turned into like a really lengthy, maybe 2 sentence thing, obviously that's not that long, but now it's pipeline inspection found in compliance, but recommended clamp installation for continued integrity. So it makes it really easy to take these free text fields and whether you want to summarize them, fix the grammar, do something custom with, once again, AI query, you can really do that very easily. This one was fun. We have AI translate. And so, maybe, I don't know the situation, but I just thought this was fun to highlight. We can more or less pass in a description, pass in, we want to actually translate it to Spanish, and now we go. It's gone through, it's translated our field descriptions into Spanish. So unlimited use cases. Really implore you to dig into AI query. And what's nice is these can really easily be incorporated into your DLT pipelines. So for instance, once again, this is that DLT pipeline. I create this inspection silver table where I want to add in that sort of cleaned up recommended next steps. All I have to do is take that same sort of function that I was leveraging in our DB SQL playground, pop it into here, and sure enough, now as it goes and creates that inspection silver table, it's going to actually create this new LLM generated field. And what's really cool is you can actually pair this with our quality control um, constraints, expectations. And so in this case, I actually put sort of a QA limit on this field. Say, hey, I want to make sure that the service recommended is one of these 7 categories. If not, go ahead and write it to like a sort of a warning table. That way I can go and review those periodically. Maybe there's some things that didn't get classified. Well, that's sort of that is a signal for me to say, okay, well now I need to go back and maybe modify this prompt. Maybe it's not picking up clamp installation all the way, and it's not categorizing it effectively. Well, now I can go back and sort of modify this prompt, add some more context on like what does clamp installation mean, things of that nature. So really cool functionality. Once again, this is a way that not only are we just preparing our data, making it really robust, but now we're actually augmenting it with AI and batch inference to allow it to give insights that historically we would have had an analyst go through, read each one of those lines, tag it as what the next recommended step is. And once again, that's a step that probably gets overlooked and keeps us from really being in this predictive maintenance mindset. Cool. Lots there. Want to just sort of dig into the last part of our data preparation, which is I talked a lot about Unity Catalog. Um, Once again, DLT is writing these tables out to Unity Catalog, and that should not be overlooked. So UC is our way to govern, track lineage on all of our assets. And so all these tables are created by that DLT pipeline. They're all governed by Unity Catalog, and that gives us a lot of things to really look into. Um, as a start, Unity Catalog really sits on top of our data intelligence platform and allows us to really start to leverage AI for even really simple things like creating descriptions of tables. So in this case, this is a pipeline summary table. Nobody likes to go and write long descriptions of what's happening in our tables. AI can do it for us. Obviously, you can edit it, you can accept it, you can do the same thing for column tables. So I can click AI generate, and it will take a little while, but each one of these now columns within this table will get an AI generated tag, which may not seem like the biggest thing, but for a lot of our other tooling, such as Genie, AI BI dashboards, Databricks Assistant, that's all leveraging these comments and these field descriptions to help recommend the best code to write, the best results for your natural language. And so makes it super easy to run through these 20 tables. You know, what normally would have been a day and a half long thing, now we can quickly accept the descriptions, edit them if we need to, XYZ. Permissions is all in a single spot, and so we're able to provide permissions on all of our individual assets. But what's even cooler is we can also really track lineage. So I think there's lots of solutions for lineage, but this is just a great example of, you can see the exact tables, whether it's a materialized view, a view, all that's pretty standard. But what gets really cool is you can also understand like what's using this downstream. And so a notebook is leveraging this right now. If you had queries that were leveraging this would all point back and give you insight to say, hey, if we make changes to this pipeline summary table, these are all of the downstream assets that would potentially be impacted. And so we should go work with those business owners and get any issues resolved there. So awesome. Our data's created. We've enhanced it with AI. We've governed it in Unity Catalog. And now it's just a matter of how can we serve this up. We talked about AI BI dashboards. We talked about Genie Rooms. Today, we showed a Databricks app. And so I want to start off maybe with this cookbook that's out there. I encourage you to look at of all the different scenarios and things that we're building, our customers are building with Databricks apps. Once again, these are sort of starter kits, I guess you could say. And so, if you maybe have some AI ML workflows, you want to invoke a model, you want to run a vector search, these are all code snippets. Excuse me. These are all code snippets to really help you get started. So there's really no excuse why if you have a model and you want to like serve it up in a really custom way, great. Go out to this Databricks apps cookbook, find the invoke a model. Here's your app.py file that will get you started and show you how you can sort of invoke those model endpoints. Same thing, we have some Dash templates as well as fast API. But great. Going back to like, that's great. Writing the code's one thing, but like deploying it, how easy is that deployment process? Um, it's really simple. And so, for instance, everybody's familiar within Databricks, this compute tab. It's where you go and you start your all-purpose clusters, your job compute, XYZ. You may have noticed a new header for apps. By clicking apps, this is where you deploy and you start the compute that your app would run on. And so, for instance, ours is this NRG health asset monitor. You can quickly point your this compute to a deployment source. This is where you have all your app.py files, things of that nature, and click deploy. And obviously, from there, you're able to get a website that's spun up that houses or shows any insights that you may want. It's really seamless because once again, it's all built on top of Databricks, and so you need to leverage a SQL warehouse to actually query data. Perfect. You can easily integrate existing Databricks SQL warehouses here. Same thing with ML model endpoints, same things with all their various assets that are created on Databricks. You can easily point your app to them all within this interface. And we're not making you develop it within Databricks. Obviously, we expect you to develop these custom apps using whatever IDE you're most comfortable with. And so we have a lot of instructions on how to sync your files, run the app locally in your computer, deploy things of that nature. So this product's still in its infancy and is being enhanced very, very fast. But customers are loving it because once again, there's always been this disconnect between the limitations of maybe what a Power BI or an AI BI or other sort of end consumption solutions can do. There's always been a limitation of those. No matter, you can always take it. You can only take those so far. And so Databricks apps, once again, really allows you to expand that, and it's really up to your imagination of how you want to leverage that app and serve this data up to your customer. So. You know, yeah, I think that's really all I want to show today. As I mentioned, just to sort of to prove I wasn't um, cheating you on writing back to the Delta table with that create work orders. This is that Delta table it was actually writing to, and so you can sort of see. I said crew and area, go give a look. It actually was able to capture that. And so once again, maybe your solution isn't to write to Delta, it's to write to something else or do something different. You can do it. We're not saying you should necessarily do this workflow, but this is a solution where start to finish, from data ingestion to getting the service order in place, it's all done in Databricks, and we think it's a pretty creative solution that we'd love for you to consider and take a look at. So with that, I'm going to get a sip of water and turn it back over to David for some Q&A.